Hi guys, welcome to Safi Mixed. In this video, I'll talk about the method of partial fraction. Partial fraction is a method which put a rational function into the sum of different functions. So first we need to know what is a rational function. A function f of x is called rational if it can be expressed in the form of the ratio of two polynomials. So we call this a rational function. In algebra, what we do, we usually take a function like this, 2 divided by x plus 1 plus 3 divided by x minus 3. Let's say we have the sum of two different terms which are in fact functions, and we want to simplify this to write this in a single term. That we do by first finding the common divisor. So taking LCM, I can write this as 2 times x minus 3 plus 3 times x plus 1, and then dividing this with x plus 1 into x minus 3. That is, we consider a common divisor, and then simplifying this, we can write this as 2x minus 6 plus 3x plus 3. From this I can write 2x plus 3x equals 5x, and minus 6 plus 3 is minus 3 divided by x plus 1 into x minus 3. Yeah. That is, in algebra, we try to put different fractions into a single rational function. Yeah, this may be, in algebra, this is really important, and we always do this thing. But in some cases, this rational function, the solution of this rational function from different perspective, from different approaches, is quite difficult. For example, if we want to integrate this function, this is very difficult. Similarly, in many cases, we want to find the Laplace transform of such function or the inverse Laplace transform of such function. So it becomes difficult. So what we do, we in turn tries to put such a single term, a single rational function into the sum of different fractions. So the reverse of this procedure is called partial fraction, or the method of partial fraction. How can we do this? And there is a simple way. So I first write the right side of this equation, 5x minus 3 divided by x plus 1 into x minus 3. So this is one of the simplest cases where the factors in the denominator are linear in the variable. When this is the situation, the solution is quite easy. We write a single term for every factor in the denominator and expresses in the form of x plus 1 plus b divided by x minus 3. Now the a and b, these are coefficients, and we call them undetermined coefficients. The method of partial fraction is to find these undetermined coefficients. And remember, there could be complex cases that I'll explore in the coming videos, but this is one of the simplest way. Now we need to find these two coefficients, and when we find these unknown undetermined coefficients, then that's the resultant partial fractions. Now, so a, b are called undetermined coefficients, and each single term on the right is called a partial fraction of the rational function. So what is the procedure? We multiply the whole of this equation with this total denominator of the left side, and if I multiply this, I can then write 5x minus 3 divided by x plus 1 into x minus 3, the whole multiplied with x plus 1 into x minus 3. This I do to the left side, and the same I repeat for the right side by writing the right side like this, x plus 1 plus b divided by x minus 3 in the whole multiplied with x plus 1 into x minus 3. So now I can cancel this denominator with this multiplicative factors, and similarly if I remove the brackets, this will multiply with this term, this will multiply with this term, so we multiply this with each fraction, and when I multiplied this with this, so this denominator will cancel with this, and when I multiply the whole of this with this term cancel, this factor cancels with this denominator. So at the end I can put the equation into the form 5x minus 3 equals a into x minus 3 plus b into x plus 1. Okay, now this is the equation that enables us to find the undetermined coefficients a and b. And remember, this is an equation that is valid for all the possible values of x. So if it is possible for all the possible values of x, it is definitely valid, it definitely holds for x is equal to 3 and for x is equal to minus 1. So I want to use these facts to find the value of x of a. So let me carry this word here. That is, now I want to put x is equal to 3 into this equation. So if I use x equals 3 in this equation, I can write 5 and then multiplied by 3 minus multiplied by 3 minus 3 equals, and when x is equal to 3, 3 minus 3 is 0, so this whole term goes to 0, and I'm left with this b into 3 plus 1. So this I can write 15 minus 3 equals 4 times b, or from this I can write b equals 12 divided by 4 equals 3. So I have b equals 3. And now if I substitute x equal to minus 1, then x equals minus 1 leads to 5 times minus 1 minus 3 equals 8 times, right? I'm putting here minus 1 and then putting minus 1 at this position, so it gives me minus 1 minus 3, and this gives me minus 5 minus 3 equals minus 4 times a, or this is equal to minus 8 equals minus 4 times a, minus with this, 4 is with 2, so a equals 2. I get this. Now if I replace b is equal to 3 and a is equal to 2 in this one equation, I get, let me remove this now, I don't need this. So what I do, I put a equals 2, I get 2 divided by x plus 1 plus b equals 3, I write this as x minus 3. So with the method of partial fractions, we are able to convert this thing back to from where we started. So we have converted a rational function of single term into fractions of two terms back. This method is called the method of partial fractions. Now, two things there are to memorize, two things there are to understand. If the degree of polynomial in denominator is greater than the degree of polynomial in the numerator, when that's the case, we call f of x as proper rational function. However, if that's not the case, that is the rational function is improper, a function is improper for which the degree of polynomial in numerator is greater than the degree of polynomial in denominator. So if that is improper, then you need to first divide the numerator with denominator like you learned in algebra, and I'll do an exercise on this to reduce the fraction, the rational function into proper form. And once that is done, then we use the method of partial fraction. The second thing, it is always the second thing which is important is that you should factorize the denominator into different factors. If the factors are linear, this is very easy then to do like we did over here. However, the factors may be quadratic, and if the factors are quadratic, in that case we use another method that I will outline in the coming videos. So this is sufficient for this video. We'll continue in the next videos, and thanks for watching.